Hi, students. It's Mr. McGrew, and this video is 3.8 Human Population Dynamics. And here we go. So, y'all know me. I like to be consistent. And let me share with you. Oh, 3.7. All right, so I need to do some adjusting here. This is actually, let me enable editing here. 3.8 Human Population Dynamics. And let's see if I can insert a row. Oh, I might have to do that later on. Okay, so there's actually there's all the way down to 3.9. But human population dynamics, 6.2, 131 through 135, all that looks good. And let's go all the way down. All right, I'll try to remember to come back to these settings here for the essential knowledge statements, okay? And so we can verify we've talked about what we need to talk about. All right, so how many people can the Earth support? What's the carrying capacity of the Earth? I asked that in a previous video, and here's the fun thing, like nobody really knows, you know? We're growing exponentially, our population's growing exponentially right now for humans, and some people project that number to go as high as 20 billion. Some people, like Hans Rosling in the video you're gonna watch, they say 12 billion by 2100. And then we'll level off, but we don't really know. You know, that number could be really high. Like if we have a family size close to the Duggars, if you remember who they were, 18 kids and counting or whatever. Or if we just have one kid per family, or in the future, if people just decide to stop having babies altogether, we could see huge population declines. So something to it. We do know that more people, more problems, right? Like for the ecosystems and for our planet as a whole, more people, more waste, more people, more pollution, more people, more resource consumption, more people, more habitat loss. These things go hand in hand for the most part, right? All right, so the book starts talking about China as a success story as far as curbing their population. Now, people in China might have a different idea about this because it's kind of a heavy-handed way to get there. We'll talk about that in a second. 1.3 billion people, large amount of people. China was very concerned with exponential growth of their population, maybe not having the food resources to feed their population. And China's really smart. You know this from the dynastic rules and stuff like that in China. A lot of times, whenever you would have the transitions of power, it would come down to like famine. So if a lot of people were dying, they couldn't eat, there was going to be political and social upheaval. And so to get ahead of that, China instituted their one-child policy. They made contraception, abortion, sterilization, all those things available and used. And I want you to know that the way that I understand it, and you got to forgive me because I'm not an expert at all on Chinese policy, and I've never been to China. So, take everything I'm saying with a grain of salt. It's just the way that I understand it. If you have special understandings or a more nuanced idea here, you're welcome to share and maybe enlighten me. But the way that I understand it is the one-child policy, they didn't take you out back and kill you if you had two kids. It was essentially a tax policy. So if you had two kids, you had to pay a lot of money in tax dollars for that second kid. It was so much so that even people that were fairly well off would choose to not have that second kid. So that's the one-child policy. Now, with that said, there was some pretty terrible stuff that I've heard anecdotally And I guess it's reported pretty well, but essentially like there's a son preference. So you end up like doing sex selected abortions, right? So if you have a daughter or, a daughter about to be born, they might choose to have an abortion as a result of maybe a screening for the gender of that kid. And that's all really terrible. They do something similar in India because of a son preference as well. There's also some negatives as far as like kids getting spoiled. Like there's a lot of stories that I've heard about this too, where grandparents and parents will just lavish all sorts of gifts and low expectations on their one child in a family. So it's kind of interesting stuff. So the one-child policy was not without some detractors and some negative things for China as a whole, but it did do a really good job of taking down their population numbers, right? They had a huge, fast-growing economy in the manufacturing center. And it doesn't take you long to realize a lot of things that we buy come from China and the manufacturing, provinces that they have there. And it's relatively cheap and good quality material, so why not? Shipping costs would be a big, negative for that, but yeah. Serious resource and environmental problems. So if they can recognize that these things are tied to population growth, then it might be smart to try to curb that population growth. More people, more coal consumption, more more pollution in cities like Beijing, which housed the Olympics, and it was pretty rough on the people that had to do outdoor sports or like outdoor running during those times. So here's a crowded street in China. Oh my gosh, pre-COVID, right? But you can see just people on top of people in some of these mega cities in China. And they have quite a few of them. I forget the number of cities like with a population over 1 million, but again, quite a few. So why do we have population growing, but it's unevenly distributed? So people move into different places, right? They might go into new climate zones that are recently becoming more inhabitable, or moving away from some that are not as habitable anymore. This is all like old, human civilization type stuff, right? So like early and modern agricultural methods, we tended to settle near the river valleys that you learned about in WAP. So Tigris, Euphrates, the Yellow River Valley, Yellow and Yangtze. You got to forgive me. I don't know my rivers very well, but that's where we saw. We can control infectious diseases through things like sanitation system and antibiotics, healthcare, and we can keep people alive longer using some of these strategies. So also to add on to agricultural methods, whenever we started really, understanding farming and then setting aside food crops and not having to follow the will of nature, if you will, to like hunt, gather, find food, those kind of things. We started to develop these massive, populations and massive cities, and culture, language, those types of things started to really take hold. But as far as agricultural methods, like this is really important. Like agriculture has completely changed human civilization, but also our environment. We're going to talk more about that in a later section. Most population growth over the last 100 years is really due to a drop in death rates. How do we drop death rates? By improving sanitation systems, by improving availability of antibiotics, by improving vaccines, by improving healthcare, and something as simple as, say, soap. If you can actually, clean your hands and, limit transmission of disease, then death rates can plummet, and that's what we see. Population in developing countries is growing faster than developed countries. And we've already spoken about this, or I've already spoken about this. The population is slow in developed countries because kids are expensive, right? And so if you still need kids to work on a farm in a developing country, there's a good chance that you're going to have more kids per family. If you still need kids to contribute to the household economy or the household, earning money for the household, then you're going to have more kids. A lot of growth. Look, by 2050, this is a projection, right? The 95% of the growth is going to be in developing countries. And by 2050, they're saying that we could have 7.8 to 10.8 billion people. As an environmentalist, I hope that we're on the lower side of 7.8 billion, or 7.8 to 10.8 billion. But again, like some demographers like Hans Rosling say that by 2100, we should level off at 12 billion. But there's some other people that say that that number is going to be closer to 20 billion. And those are two very, very different numbers. Should the optimum sustainable population be based on cultural carrying capacity? So cultural carrying capacity means not necessarily the maximum that we could fit in the environment. That would be environmental carrying capacity. Cultural means a shift in the desires for people to have a relatively small family. And that's really what we see. We see more people choosing to have 1 or 2 children in their family because kids are very expensive. It's cheaper to have fewer kids. But also, the family size is more manageable in things like cities. So like we said before, it's very difficult to have a population, a high population in your household of 5, 6 people, and then, truck around and move 5 to 6 people. Now, if you have, a big van in your family or something like that, and you can get around and take care of all your things, good for you. But generally speaking, people are having fewer kids because of the ease of having a smaller family size. Also, kids are expected to survive. We already talked about that with replacement level fertility. If kids weren't expected to survive, parents might have more of those kids to make sure that they have, kids that make it to adolescence and then in early adulthood and then into adulthood. All right, in terms of human population growth, guys, hunting and gathering way back here, 5 million years ago, oh my gosh. So Homo sapiens sapiens only been around for like 200,000 years ago, but 200,000 years, I believe. That's arguable. But back in the day, like even our early ancestors, right? Our population was super duper low, very, very, very low. And it stayed low for a long period of history. In the agricultural revolution, we started to see increases, right? Saw a dip for the plague. And then after the Industrial Revolution, we started to really mechanize things, increase quality of life, really decrease our death rates because of things like sanitation, soap availability, those types of things. And so post-Industrial Revolution, our numbers have climbed like crazy, and we're still in the middle of this exponential growth trend. Some people say that we're on the other side of this, but right now we're going to assume that we're still growing exponentially. And do you see the question mark here? By 2100, are we going to level off at 8 billion people? I don't think so, because we're already very close to that. Are we going to level off at 10 billion? Hans Rosling says that we're going to be closer to 12 billion, but some people, look, it's not even on the chart, but some people say that we're going to be closer to 20 billion people by 2100. Average annual global growth rate, you can see that we're in decline as far as growth rate, right? Now, please be careful and please be mindful of this. That's not to say that our population is dipping. This is the growth rate, the rate at which our population is growing. So again, we're still going to assume that we're growing exponentially, but the rate at which we're growing in the past, 70 years has declined. And so you can see it ebbs and flows, right? But a general downward progression for the growth rate. Here's a little timeline. Hunter-gatherer societies, 50,000 BC. Projected human populations, like again, very much an approximation, but this is relatively low, growing. Oh my gosh, growing like crazy. So since 1950, after our first billion, let's see, how long did it take us to get to, 2 billion? That was about 120 years or so. And then 2 to 4 billion, that was only 50 years. 4 to 8 billion, projection in 2024. We might break that actually. So this might be a little bit dated information. So there's that growth rate again. Where population growth occurred, guys, remember we said it before. Population growth is really occurring in less developed countries. More developed countries like the United States, kids are really expensive. Urbanization has led to this decline. Education of women is a big one too. That's one thing that we talked about before, and we will probably talk about again. But in less developed countries, you might not have that urbanization that's occurring just yet. You might not have improved social status and uh, education opportunities for women. You might not have availability of birth control, sterilization, abortions, those types of things. And so therefore, population is going to go up. All right, so I need y'all to know that China and India are the two big population drivers, and they're very, very close to one another. I doubt I'm going to ask you to know the numbers here. As you can see, they're projecting by 2050, India to surpass China in terms of its population growth. One of the reasons that China slows down is because of that one-child policy, and I do want y'all to understand those things. India is also trying to do cultural pushes to celebrate girls being born to a family and to kind of get people, their population, to embrace this idea of a two-child family rather than, you know, multiple kids, 5, 6 kids in some places. You can see United States is going to be in third place well into 2050 in terms of our population. So I want you to know that the United States is a very populous nation, but we are nowhere nearly as populated as India and China. So 439, you can think about that as like 0.4 billion versus 1.7 and 1.4 billion by 2050. That's pretty serious stuff. All right, world population in billions. These are projections, right? And they're all based on data from 2008. I'd be interested to see how that changed for 2020. If you want to Google those and check them out, you can see which one is actually being followed here. But look, you have low fertility variants that actually start to have a declining world population by 2050. But I don't believe that that's where we're going to be. I think we're probably trending on the higher side, right? This is the US Census. And by the way, 2020, hopefully everybody is participating with the census and like those types of things. It helps us to understand what our population is actually doing whenever we get accurate counts. So that's why there's a big push for the census and a big push for accurate counts. We have a large range. Hopefully you recognize like 7.8 to 10.8. That just looks like a 3, right? But 3 billion is a lot of people. Demographers, the people who study these things, really have to understand the current estimates. They have to get good data, like with the census. They have to make assumptions about fertility trends. You know, is the culture going to be there? You know, right now, we looked it up before, the replacement rate is like 1.7. Total fertility, excuse me, is 1.7 for the United States. And could that creep up in the future? You know, if you have a really good economy, there's a good chance that that could creep up. If you have a bad economy, that could go down, actually. And each of these models is based on different assumptions for those things. All right, and that's kind of a tough job. By the way, a demographer is a person who actually studies these populations and understands these populations. This could be locally, but it could also be nationally or globally. If you're interested in this, you know, demographers nearby can look and see, okay, well, how many grocery stores do we need or could be, you know, sustained in Kingwood? How many can be profitable? And y'all know that this changes just in the last few years. A big grocery store, Randall's, left this area, but other ones are coming up. Like H-E-B now has 2 locations in Kingwood, one on each side of 59. Kroger, if you know, like has 2 big locations here in Kingwood as well. So demographers help to understand those things, right? As well as economists. But and here's that same data. Guys, I want you to know who Thomas Malthus is. Thomas Malthus was an early demographer. He basically had this idea that human population would grow out of control and we would not have enough food to feed ourselves and we would have a population collapse. His ideas was about overpopulation and overconsumption, and he was very concerned about things like increasing population rates, even back in 1798. So technology, not necessarily like the tech in your hands and your phone, but agricultural technology has really allowed us to grow as a population. Availability of things like nitrogen and phosphorus fertilizers have really helped our population to grow because that provides a good, stable food source for a growing population. But is it going to grow indefinitely? We're already doing things like running out of phosphorus or availability of phosphorus. So my answer to that would be no, but I think that we're going to hit a cultural carrying capacity before we hit a ecological carrying capacity. And by the way, I think a cultural carrying capacity will be a lot softer than a environmental carrying capacity, meaning like, you know, oh my gosh, there's death, disease, those kind of things, and so forth. Yeah. All right. How do we change the world to meet a growing population needs? Agriculture is a big one, right? Because of humans, we've taken out a lot of our natural predators. You can see a picture of a dead wolf here, right? We're using we're using non-renewable resources faster than they could be replenished. I wonder if that's a typo. And we are disrupting these chemical cycles, these biogeochemical cycles in big ways, in really, really big ways. So these are all consequences of, you know, us altering our environment and accommodating for growing populations, right? These are the things that we do to degrade the environment. I like this slide. You should probably spend some time to look at it really carefully. All right, so I want you to know about these limiting factors. We've already talked about some of these things, like as far as disease, as far as resource availability, those kind of things. But the number of predators, loss of food, lack of sunlight in terms of plants, right? Accidents of nature, or, you know, natural events like a hurricane, tornado, those types of things. Those are extrinsic limiting factors. Intrinsic limiting factors would be inside of the population. So factors originate within the population, behavioral changes that can cause a lower birth rate. So maybe, you know, the mating dance isn't recognized anymore in a certain population. Density dependent, those that become higher with people or populations closer together. I would think about parasites, right? Disease transmission, those types of things. And density independent factors would be outside. Like, it doesn't matter if there's a lot or a few. Like, I would think about a hurricane or something like that. I want you to be able to think about human and wildlife populations with all these things. So please know extrinsic versus intrinsic limiting factors and density dependent, density independent factors. Again, we've kind of hit on this, but raw material availability, energy availability, like these are very much limiting factors, okay? And this is true for animal populations too, but it could be, you know, instead of timber for a house, it could be twigs for a nest for a bird, okay? It's just that simple, or it can be. Guys, I want you to know this formula, and I think I've already mentioned in another video, I'll mention it again. Crude is by 1,000, so population per 1,000. And I want to do some practice with you here in a little bit. So these are really good. Notice on these formulas here, these are both rate of population change, right? Percentage. They give you a percentage value. The crude value is per 1,000. If you do the actual, it's based on the actual population. So if they give you an actual population, do this, right? Use that population number. Don't use per 1,000. All right. Sorry, I got to speed up a little bit here. They're doing the announcements. I want to share with you me working out some of these problems. I think this will still work. I really hope it does. Okay. So the question, hopefully you can go back and forth. And I've given you the answers here too. If you have 22 births per 1,000 people and 9 deaths per 1,000 people, calculate the world growth rate. So our births is 22 per 1,000 and our death is 9 per 1,000. Well, the percent growth is going to be 22 minus 9 over 1,000 times 100. Okay? So really all you have to do is plug this into a calculator, and here, I'll show you in mine. 22 minus 9 divided by 1,000 times 100. So that's how you get their 1.3. And that's a good answer. But I want you to see that you could do this a little bit simpler. If you cancel out your zeros, then it's 22 minus 9 divided by 10. So that's if you look this up, you might see some people that online that automatically drop those zeros, and that's totally fine. All right, so the next one here, it says in 1950, the population of a small suburb in Los Angeles was 20,000. The birth rate was 25 per 1,000, and the death rate was 7 per 1,000. So we can actually do a proportion to help us to understand these values. Well, if it's 25 per 1,000, how many per 20,000, right? In your calculator, you can go 25 times 20,000 divided by 1,000. And I see that there's going to be 500 people born in this city. And here's another proportion. There's another way that you could do this too, but I like this. 7 times 20,000 divided by 1,000, and you get 140 deaths. If we go back to the question, it says there's 600 people coming in from immigration, I for immigration coming in, and emigration was 200, that means people going out, okay? And just as a reminder, look, births plus immigration minus deaths plus immigration. So we can manipulate this, births minus deaths plus immigration minus emigration. So now I know this is the total population change. 500 born minus 140 deaths plus immigration is 600 minus 200. That one's easy. I can do that in my head. 400. What is that? 360? 500 minus 140. Yeah, 360. So 360 plus 400 is 760 people added, right? So you have to be careful. That's not the final answer because it does say the original population was 20,000. So the final population should be 20,600 people. Okay? So, oh, shoot. I hope this isn't too big of a problem. So again, the answer is 20,760. If we continue on here, you can see these are more current stats, by the way, 2013. It's difficult to find good stats for these things, but look, constant fertility, we could go up to as high as 30 billion people. Isn't that amazing? Here again, slow growth and then exponential growth in the modern age from the Industrial Revolution. All right, the other formula that you need to be familiar with is the rule of 70. So the rule of 70 is just that 70 divided by the percent increase, okay? So if we assume exponential growth, then we can manipulate this value, and this is only with exponential growth. So again, you have to assume exponential growth for these to occur. It says 1.7 in 1995. So all you have to do here, let me share my screen again. So if we do 70 divided by 1.7, I can get 41 years. This is the doubling time. It's really 41.17, but this is the doubling time in years for a population, okay? So back to this. Hello, hello. Really good. 41 years is the doubling time, and you could add that time to the year 1995 to get 2036. I bet you're really good at math. I bet you could find the percentage if I gave you the doubling time, and that's what we're doing in that problem. Okay. All right. Let's see. By the way, this is what that kind of curve looks like. The higher percentage increase, the lower the time to double, right? Because you're growing faster. And so the lower percentage rate increase, the longer it would take to double the population, right? And again, this is all a function of exponential growth. If you ask Mr. Conley, he could probably explain it a lot better than me, but just know that it works. Hello. All right.
Where's your crazy hat?
Oh, I know. Where is it? All right. I can't talk right now. Sorry. Less developed countries typically have less per capita income. So that's one of the reasons why they have smaller family sizes, right? We talked about that. Kids cost a lot of money. And that's it. So we'll talk about 3.9 later. I wonder if I can go back. All right. So here's the essential knowledge statements. Let's see if we hit them. Birth rates, infant mortality, overall death rates, access to family planning, all those things are reasons for populations to decline. And we hit a lot of those things and spoke about them in detail. Factors limiting global human population include the Earth's carrying capacity and the basic factors that limit population growth as far as Malthusian theory. And we talked about who Thomas Malthus was and what he said about, those limiting factors, right? So McGrew. Hello, hello. Populations can be affected by both density independent and density dependent factors. Density independent means like the population isn't going to be affected. Hey guys, quiet for a second. And then the rule of 70. They're specifically talking about the rule of 70, so I need you to be able to do those kind of calculations, okay? All right, bye for now. Look for video 3.9 coming up.